All right, we're ready to start our lesson. So this is lesson 2, and this is the command line part 1. So this top part about operating systems we already kind of covered. So we're for Windows users, we want to use git bash, and that'll give you the bash shell. So and then there's a little overview. So we already covered some setup, so how to open a shell, how to create a working directory for the course and a lessons directory inside that, and we copied today's lesson from GitHub to your lessons folder. We're now going to cover some basic commands and skills, and then we'll also cover some customization. In fact, we already played a little bit around with customizing your Finder window. Okay, so also, I should point out that you can either follow along here with the GitHub page, or if you wanted to, you could open up that that lessons folder, that lessons file with your text editor or something. But I think for today, it's going to be easiest. You don't need to actually open that file. You've got it on your computer, and we can just follow along on the web page. So I'm going to make this window, I'm going to do kind of side by side. I can show you how to do this later. There's some different tools. I think Windows and Linux make it really easy to make your window take up half the screen. Mac is, you need to install a program. I actually have one called Spectacle that does that. And if you're a Mac user and you want to do that, it's a nice program. I can show you more about it later. Anyway, but I've got my split screen here. So on the right, we've got the kind of commands for the day that we're going to go through, and on the left, we've got a terminal window. So we already covered some of these commands, but let's just go through them again briefly. There's pwd, which is print working directory. So that'll show you where you are on your computer. There's ls, which is list the contents of your working directory. And ls has a number of different options. It's a very powerful command, actually. In its most basic form, it will just list the files or directories that are in that directory. But there's also a command called ls-l, which is long format. So this will tell you not just the names of the files, but also when they were modified, how many bytes they are composed of, who the owner of that file is, and the group that's associated with that. Don't worry too much about that now. Also, will give you the permissions. So this is a code, and again, it's not too critical for this course, but basically this first character tells you if it's a file or a directory. If it's a directory, that'll be a D instead of a dash. Then we have you, the user. This says you have read and write permissions, but not executable permissions. This is not an executable file. Other people in the group have, which is this staff group on my computer, have read access but not write access, and other people using your computer have read access but not write access. So that's long format. This comes in handy in certain cases. There's also you can do ls-a, which shows you all files, including dot files. Now, in this particular directory, we don't have any dot files, but we do have these sort of links type dot files, which are dot and dot dot, and I will explain what those are in a minute. But basically, dot represents the current directory, and dot dot represents one directory above the current directory. So these are kind of like, in a way, you can think of they exist in this current directory, but they're pointing to other places on your computer, either to where you are now or one level above. Because everything on your file structure is hierarchical, right? Folders exist inside folders, and it's kind of a tree structure that describes all the files on your computer. So what we're going to do today, and a big part of Unix, is navigating around this tree structure. So we have this idea of your present working directory, or printing the working directory that you're in. That's where you are now. That's the folder you're in. And then you can go down deeper into deeper folders, or you can go up higher to higher levels. You can go higher and then back down into another level. you can refer to, in those cases, you're referring to other locations via relative paths, right? One folder up and then another folder down somewhere else. But there's also a way to specify the absolute path, which is on my computer, in this drive, in that folder, that folder, that folder, all the way down to where you are now. That's an absolute path. And oftentimes, maybe if you're working on a big cluster or something, you need to specify the absolute path so that there's no ambiguity about what you're talking about. Okay, that's a little preview. So we've also done CD, but we can do, so if we type, I'm going to go to this fourth one here. If we type just CD, change directory without anything, that's going to take us to our home directory. We can then type CD SIO 209 because that's in our home directory. And then we can type CD lessons, and now we're back in lessons. Instead of typing just CD, we could have typed CD, this little squiggle or tilde. That's the same as typing just plain CD. What that does is that little tilde says my home directory. It means whatever the path of my home directory is, I'm going to go there. So if we type CD tilde, that'll take us to our home directory. Now, the other one is CD dash. That will take us to the previous working directory. So we type CD dash, that'll take us back to the lessons folder, and it will give us a little message saying, hey, here's where you are now, just as a reminder. So if we type CD dash again, it'll take us back to where we were before. So it's kind of alternating. And now back to lessons. Okay. Now we have this idea of absolute and relative paths that I was just talking about. So the dot represents the current directory. 2 dots represents one directory up. 2 dots, then a slash, which is sort of separating to the next directory. So it says we're going to go 2 directories up. Dash is the root directory. This little tilde is the home directory. So if we go CD ... that will take us to one level up, SIO 209. If we then go CD ... again, that'll take us to our home directory. If we go CD dash, it'll take us to the root directory. So we can type ls here. This is now the total contents of the drive that we're on, of our hard drive. So you should have users. This is where you're usually working, but you also have system stuff. You have library applications live there. You have this folder called bin. Generally, you don't work in this folder, and you don't want to change things directly in this folder unless you know what you're doing. But this is where this is the root of our drive. So if we go back, if we type CD again, it'll take us back to our home directory. And we can go back to SIO 209, and then you can type /lessons. So we can move 2 directories at the same time. We don't have to go one at a time. We can go down into that lessons folder with one command. Everybody kind of following along with this? The only way to really get the hang of this is to just practice, and eventually you'll get more competent with it. Okay, moving right along, we have now creating, moving, and removing files and directories. So this goes to the question we just had. So we covered mkdir, or make directory. So what if you want to remove a directory? So let's first of all make a new directory. So we're in lessons. We're going to type mkdir, and we're going to make a directory called temp. So this is, if I make a directory that I know I don't want to keep for very long, I can call it temp, and that tells me that it's only temporary. So I made that directory called temp, Now here's a little thing we can try, ls-l. So what this shows you is it's listing the contents, but now you can see that this one we just made here is a directory, not a file. So it has a D as that first line. Also, it's now not just readable and writable by you, it's also executable because it's a directory. So when you execute a directory, you look inside it, you go inside it. So that's what it means to be an executable directory. So everyone on the computer, everyone that could access your computer would have access to look inside that directory. As it's set up now, you can change these permissions. Okay, but anyway, the point of this is we made this temporary directory, and let's say we decided we don't want it. So we can type this command rmdir, remove directory, temp, and now we've removed the directory. If we type ls or ls-l, we don't see that directory anymore. Okay. Now, if there are files inside that directory, this command won't work. It'll give you an error and say the directory is not empty. You can't delete it. There's two ways you can get around that. One is you can remove the files that are in that directory first, and then remove the directory, or you can remove recursively that directory, which will remove the directory and all the files inside it. And I'll show you how to do that in a minute. Okay, there's a few more commands now for working with files that are really useful. So there's one called touch, which will create a file and not put anything in it. So we can do touch, we'll call it foo. Now if we ls, we now have this file called foo. If we do ls-l, you can see it has 0 bytes, so there's nothing in it. All that touch did was just create a file that's empty. And if the other thing that touch can do is it can update the date and time that a file was modified, or you can actually specify exactly when you want that modification date to be. So touch has a lot of nice features. Another thing we can do, so let's do, okay, did everyone install a text editor? Yeah, so let's open up our text editor. We can use Atom for now. Okay, remove that. Now I'm going to go in my text editor. It could be Atom, could be Sublime Text, could be Notepad, whatever you want. And we're going to go to Home, SIO 209, Lessons, and we're going to open up foo. So here's you can see it's an empty file, so we can add some text. So you can write anything. We'll say, okay, write whatever you want, maybe just a few lines. And I'm going to hit save, or go to File, Save. And we can now use this command called cat. Well, first of all, we can do ls-l. You can now see that that foo file has 52 bytes. So we can type cat foo, and now it will print out the contents of that file. So if we go here, the most basic version of cat is a really versatile command. There's a lot of things you can do with it, but the most basic thing is to print the contents of a file to what we call standard output, which is printing to your screen. So we're going to cat this file called foo. It's got these 3 lines. but there's another another thing we can do. So we can say cat, instead of typing cat and the name of the file, we can type cat, this single greater than symbol, or it's called a redirect operator, and we can redirect output to this file we're going to call bar. What this is going to do is it's going to bring up a prompt, it's just going to bring up a cursor without a prompt, and we can now write some stuff. So sorry, this is line 1 of bar. Again, doesn't really matter what you write. And when you're done, I always like to add a new line. So you can see my cursor is just below the last line of text. I'm going to hit Control and then C at the same time, and that's going to terminate that command. Control C is something you're going to use all the time in Unix. So it's a way to cancel a command, or in this case, kind of terminate it. You've already written those 3 lines, so that'll stay there. So now if we type cat bar without any greater than symbol, we're going to see the contents we just made here. Now I'm going a little bit out of order, so I will adjust these. In fact, I'm going to make some changes to the lesson kind of on the fly here, just FYI. So I want to do okay. So another thing we can do with cat, so we have these 2 files. We just created one with the text editor. We created another using this redirect operator, and we printed the contents of each of them using cat by itself. We can also cat multiple files and redirect those to a 3rd file. So this is kind of combining those 2 things. So we can type cat foo bar, redirect that to, let's call this foo2, or we can call it foo bar. So we're going to cat these 2 files together and create a 3rd file. So we type ls, now we've got those 3 files plus lesson 1 and lesson 2. And if we cat foobar by itself, we see now the contents. We've created a 3rd file, which is those 2 files smushed together. So this can be really handy. Another thing we can do is we can append. So we can do cat, instead of a single redirect operator, we have 2. So this is going to append. We can append to, say, foobar, and we can then type some more text. And if we now type cat foobar, you can see we've now got everything we had before plus those 2 lines we just added. So this is appending content, not kind of replacing. Because if we had done cat foobar like this, we can see that we now overwrote the previous file that was there, because we had a single redirect instead of a double. So this is not appending, this is just replacing. So you have to be careful when you when you use this kind of redirect that whatever file you're going to target is going to get generated. And if it already exists, too bad, that's gone. So you need to be aware of that. This is not how you necessarily typically want to create text files. You probably want to open up your text editor. But if it's a really short command, or if you're including this in some kind of bash script or that kind of thing, it's very handy. A couple more here. So there's copy. So this is to make a copy of a file. So if we wanted to copy foo to foo2, so the way this works is you copy from the first file to the second file. So now, if we cat foo2, it's the same as the original foo up here. We could also move a file. So this is either moving a file to a different place, or also just renaming a file. It's the same thing, really, in the Unix way of thinking, moving and renaming a file. So we can move foo2 to foo3. Now we no longer have foo2, but if we cat foo3, it's the same. It's now what foo2 was. We just changed the name. Now we can also remove a file. So we can remove foo3. Now my terminal is going to ask me if I really want to do that. Yours probably will not, because I have mine set up a little differently, and I can show you how to do that. But I'm going to type Y. Yes, again, yours probably doesn't ask you if you want to do that. And finally, we can, this is sort of a slightly more advanced thing, but we can make a link. Sort of like on your Mac you have aliases, or Windows you have shortcuts. On Unix you have these things called symbolic links. So you can make a link to another file on your computer. This is really handy. I use this a lot when I'm working with large files, like DNA sequence files that are multiple gigabytes. I don't want to maybe make a whole copy somewhere else, but I can make a link to that file, and then I don't have to make a copy, or I don't have to move it. I just link to it, and my computer says, oh, you want that file. So we can type ln-s, and we're going to, we can type foo, and then we can call it link to foo. We can call it anything we want, but we type that, and we type ls-l. You can see that link to foo now has an arrow pointing to foo. So if we do cat, but that file only has 3 bytes. So it's a very small file, but it links to foo. So if we type cat link to foo, we'll get the contents of foo. So this is a symbolic link, and this is really handy for a lot of things. Question?
You maybe clarify it a bit more. So the link itself, I mean, it would be just like a shortcut, for example.
Yeah.
Windows. So the only use is, why wouldn't you just reference the file itself directly instead of like referencing the link?
Oh, so in this example, the question is, why wouldn't I just use the file instead of the link?
Yeah.
So here I could move link to foo to, say, my home directory. And now if I go to my home directory, I have, sorry, there's a lot going on here, but I have,
So it's just to organize it better, I guess.
yeah, I have link to foo now here, so I can move that back.
Copying the entire file.
Yeah, it's just a way to, kind of organize things. It's hard to see exactly how it's useful in this situation, but it definitely can come in handy. Another question.
Does this work on PCs?
So I don't know about PowerShell. Are you using Git Bash?
Yeah.
Okay, it should work. Is it not working? No. Okay. I can't guarantee that everything will work on Git Bash the way it works on more traditional Unix systems. But yeah, we can take a look